Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question number 4 on our 2018 Euclid Math Contest. So we've got a light bulb question and a written question. Let's just take a look at both of those. The positive integers 34 and 80 have exactly two positive common divisors, namely 1 and 2. So the only factors they have in common, if you listed out all their factors, there'll be a lot for the 8 one, so I'm regretting this. 10, 16, 20, 40, 80, 2, 4, 6, 8, 10. Yes, it should be 10, yep. So the only ones they have in common are the 1 and the 2. And that's what they mean. How many positive integers n between 1 and 30 have the property that n and 80 have exactly two positive common divisors? Okay. So this question, might seem easy if you can see why you would only ever have two positive common divisors. It might be a bit trickier otherwise. And you definitely don't want to go all the way through numbers 1 through 30 and say, okay, let's list out all their factors and figure out what is in common with this big list of the factors of 80. You definitely want to be looking at, okay, why would you ever have only two positive common divisors? Okay? And the answer is prime numbers. It's no coincidence that it's 1 and 2. If I told you that two numbers have 1 and 6 as their common divisors, well, if 6 is a factor of both of them, then surely 2 is, and 3 is. And then you get at least 4 factors there. If I told you two numbers have a common divisor of 4, not a greatest common divisor, mind you, just a common divisor of 4. We know that 4 appears on both their lists. You sort of automatically know 1 is on that list, guaranteed, but also if 4 is on that list, so each number is a multiple of 4, well, doesn't that mean every number is also a multiple of 2? Okay? So the only way you're going to only get two numbers is if you're looking at 1 and that other number. And that other number better be a prime. So we can write a little bit of this down. You don't have to. Again, it's a light bulb question. But we'll write a little bit of it down. So notice two numbers, A and B, have exactly two numbers in common. Oops. Two common positive divisors, I think they said. If those divisors are 1 and a prime. We might call it P. Okay? And the reason being, well, what if it wasn't a prime? Well, if not, and 1 and n are divisors, and n looks like p to the k, then 1p, p squared, all the way up to pk. That'd be k plus 1 factors in common. Or if n was equal to c times d, then 1, c, d, and n, that's at least 4 factors in common. So they can only have 1 and a prime. A step up from this would also be to say, something that's, it means the same but sounds more impressive, is A and B must have a prime number as their greatest common divisor. But we're not really going to need that here. Now I just need to go through, okay, 1 and 30, and which numbers have only a prime in common with 80. Now 80 is quite nice, because look at the primes that 80 could have in common. It's 16 times 5, or 2 to the 4 times 5. So only 2 and 5 can be in common. Okay? So either you have a 2 or a 5. You can't have both. So let's just look at these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I'm pretty sure you know how to count. So I don't know why I'm reading these out as I go. At least I hope you know how to count if you're doing these contests. 28, 29, and 30. Okay, so we can just go through one at a time. Do we even have a factor of 2 or 5? So no, 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 that does have a 2. So basically we can cross out anything that's not even or not a multiple of 5. Okay, great. So we're looking good. Now, what if you have more than more than one factor of 2? Because 4 and 80 have 4 in common, so we can't have that. Same with 8, so we can't have any multiples of 4 on the list. So that crosses out a few more. Okay. 16, can't forget that one. Okay, what if you have a factor of 2 and of 5? So that'd be something like 10, or, well, 20's already gone, but 30. There we go. And we've narrowed our list down now. If we take a look, 2 and 80 just have 1 and 2 in common. 5, just 1 and 5. 6, 1 and 2. 14, 1 and 2. 15, 1 and 5. 25, 1 and 5. 2 and 13. Sorry, not 2 and 13. 1 and 2. 1 and 2 for 18 as well. 1 and 2 for 22. Okay, so there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. We did want the number of numbers, right? How many positive integers? 9 such integers. Let's say between 1 and 30. Okay. So there we go. That's a part all done. You didn't need to write any of this stuff down. If you just wanted to say 9 and we're done, that's okay. But I've written it down. I've written down a list. I didn't explain why everything got crossed off that did, so if I accidentally crossed something off that shouldn't be and the answer is 10, or I left something on here that should be there, I left something on here that shouldn't be on here and the answer is actually 8, and I just put 9, I would lose marks, but I do have a little bit of my work showing, and that's good. Okay. So, for B. A function f is defined so that f of 1 is 1. If n is an even positive integer, then f at n is the same as f at a half n. Because it's even, so we can divide by 2. We can have the number. If n is an odd positive integer with n greater than 1, then f at n is f of the previous one, which will have to be even, plus 1. So, for example, f of 34 is f of 17, and then that f of 17, because it's odd, becomes f of the previous number, 16, plus 1. And we're just being asked to determine the value of 50. That doesn't seem that bad. We've been given a definition. Let's just sort our way through it. So, f of 50, well, that's even, so it's going to be the same as f at 25. And there's not really a whole lot to write down here, so I would just say something like 50 is even. You probably don't even need to write that, but it is a written question, so you should write something. Showing your work is good. Okay, well, f of 25 is odd, so this is going to be 24 plus 1. So 25 is odd. Okay, f at 24, well, that's going to be f at 12, because 24 is even. And then 12 is also even. This seems kind of simple for question 4. I mean, I know the questions aren't supposed to be super hard at this point, but this seems like sort of a can you read question. Alright, now f at 3 is going to be f at the previous one plus 1. And don't forget this other plus 1 still stays around. So we could even say plus 2. So 3 odd. And then that's f at 1, because 2 is even. And then f at 1 equals 1 by definition. So this is 3. And that's it. Kind of peculiar. I wonder, does this function mean anything? I feel like this might be the digital sum for binary numbers or something like that, just because of how often we're dividing by 2. But yeah, that seemed suspiciously easy. Did I miss something? F at 1 of 1, F at n is... It's not like it's split into an F at something plus an F at something, so... No, this is just a very basic recursion question, but I'm pretty sure that this might have some sort of meaning. I think that if I wrote F of 50 out in binary, I might get 3 1s. I don't know, let's find out. There's 132 in there, and then 116. And that gets me up to 48, and there's no zeros, and sorry, there's no 8s, there's no 4s, there's 1, 2. Huh. But, oops, wrong way. But 34 would end up being F at 17. F at 17 would be F at 16 plus 1, so that'd be 1 plus 1. 34 is, yeah, it's 32. No 16s, no 8s, no 4s, and a 1, 2. Huh. So that would end up being 2. That's very curious. I don't know if this is actually doing the digital sum for when the number is written in binary, but if somebody wants to confirm it down below, I would love to see someone confirm it or explain what this function actually represents, because I feel like this function was probably plucked out of someone's notes for some other reason and said, that'll be a good 4b, because it was a very basic definition, but it's a good question nonetheless. But yeah, if you want to leave a comment, or if you want to leave a comment because you have a different way of doing questions, I always like hearing different explanations, different solutions, different ways of thinking about them, because it helps me broaden my horizons. And I'm sure you're watching these videos because you want to broaden your way of thinking, and there's some reciprocity there. So leave a comment if you want. Feel free to like or subscribe or all that fun stuff. But either way, I will see you guys for question number 5, halfway point of our Euclid, in the next video. Until then, take care and have a wonderful day.